So I haven't really solved it if I get an h on one side and an h on the other side. Sometimes people solve for one h, but then you have h's on both sides. That's not solved for h, right? So my claim to you, so that you can really believe that I'm insane, is there are not two h's up there. Now watch. If you don't believe me, how many 2's have I written down here? How many 2's? One. If I distribute it, it looks like there are how many 2's? Four. It's getting me a little worried. Two 2's is what it looks like, right? It looks like two 2's. Why do we know it isn't? Because I can take a 2 out. So what can I do here? Well, first thing, let's kill the fraction. Just get that the hell out of the way. Multiply everything by 2. I like it. Cancel. So you get 2a equals AH plus BH. I'm trying to solve for H. Somebody pointed out there are two H's. That's a problem, but there aren't really two H's. What can I do? I can take an H out. I can undistribute the H. Just like I can go back, I can undistribute the 2, and then there's 1, 2. So if I take an H out, what does it look like? I take an H out front. There must have been an A here to make ah. And there must have been a B there, A. And then you're one step away. I'll at least stop there. I'll give you something to finish. So whenever there's more than one variable that you're trying to solve for, get them everything on one side that has that variable and factor it out. Undistribute it. There really isn't more than one of those things. Just collect it and take the one of them out. Sort of a magic trick, but that's how distribution works, right? So just undistribute, and you can pull them all back together. Okay, I like it. Next thing about Dragon Ball. Mini TNs. No Dragon Ball launchers. Okay. Anything else from homework stuff? Yes.
Sorry.
That's all right.
68 as well.
Oh, same exact idea. You're trying to solve for C. Are all the C's together on one side?
So I would just move one of the pairs of C's to the other side and then...
Well, which one specifically? Who's in the wrong place? Which thing with a C in it? BC is in the wrong place. Subtract it over. Take the C out. Divide by what you don't want.
Okay.
I like it. Just make sure you guys understand. This is not done. I don't want somebody to turn this in and say, well, that's what you put on the board, man. I left something for you to do. How to get H by itself. What do you got to get rid of? Don't say it. Just do it. Yes? 35 on 2.3? So later in this class, I think I said this before, this is the equation of what kind of thing? Does anybody know what this would look like if you graphed it? That's in our near future, the graphing stuff. No? If you solve for, they want you to solve for y, which is what we would do. Because you get it in good old mx plus b form. And what would that be? With m and the b, the slope and the y-intercept, this would be a straight line. When all of your variables are to the first power, it's a straight line. If there's anything to a different power, it's curvy somehow. Like squared would be like this, parabolic, right? Weird shit. That's in our future too. All right. Do you have to know any of that for this problem? No. They say solve for y, but I want you to realize what they're getting you ready for. Did you say solve for y, right? Yes. How do I start to get y by itself? This has got the y in it, so what do I want to get rid of first? Now, watch. Some people will do this. All right, now, that's wrong. Don't write that down. That is very, very, very wrong. Did you divide both sides by 5? No, so you did not do the same thing to both sides. You'd have to divide the whole side by 5, and then you make this fraction that really wasn't necessary. So, almost always, when we're solving equations, we find our variable we're trying to get a loan, we get that term by itself first. So why is 5y not by itself? Stupid 2x won't leave it alone. So how to get rid of the 2x? Subtract 2x. Please, dear God, don't say 8, anything. Are these like terms? No. Now some of you guys, I'm going to write it like that because that's how it's read. But some of you guys might want to put that in front. You're used to the mx plus b. That's fine too. One last step. What's the last step? Divide by 5. And again, you could stop here, or you could put 5 underneath each piece. You could say instead, you could say, so this is fine, or you could split that up and then reduce the 10 over 5. So you can either stop here, because you got y by itself, right? Y equals this. Is that, you guys see what I'm saying? So they ask you to get y by itself, you can stop. Or you could write 5 underneath each of them. Either way is fine. Yes, back there.
Is that number 35?
35, yeah, I think so. Yeah. So what's the idea? You find where the variable is. You get that term by itself first. You almost always divide last. It's just kind of the natural way things work when you're solving equations. Okay, yes?
I don't have the book on me, but I think it was either number 9 or number 10 that for people that had no numbers in it, it was just straight letters.
Oh, yeah, they both do. Yeah. And they're both the same function, actually, the same formula. It's just one wants you to solve for, I don't know if I trust these. I don't know whose these are. Has everybody got this here? That wants it? Okay. Yeah, they both have this formula. One solve for B, one solve for H. They're both the same idea. Stanley. Turn them off, preferably. Or at the least turn them down. Sorry. If I said solve for B, what do you want to get rid of? The H. And what's the operation? In multiplication, so I want to undo multiplication, I got to divide. You get too many people subtracting H off, that doesn't work. Some of you guys might see me write subtraction can't cancel multiplication. Well, yeah, it can't. That's not his job. It didn't have that much power. To cancel multiplication, you got to divide. What if I said solve for H? Well, you would divide by B. Yeah. Right. So if I said solve for B, that's it. Right there. Now, real quick, let me interject a couple of things myself here. I've seen things in the homework that looks something like this here. Like somebody will write this. Let me even just do this. And then on the next thing they say 16a equals 2. I mean, there's just no, you have to show me the work. Even if you get it right. Some poor person out there got a lot of stuff right, but I said redo it because they showed me no work. That's not going to fly with me. Answers are nice. Work is the most important thing. That's what I'm here to help you with. If you don't show it to me, I can't do my job, so I'm going to make you redo it. How the hell? How does this work? Well, how would you get the A's together? You have to subtract. All right? You'd have to subtract 70. And you don't end up with 16 then, do you? You end up with 2. And then what's on that side? Negative 2. Yeah. So you have to, I'm trying to make you show work so I can help you with what I can, and so you can really make sure you're doing things correctly. Your brain goes, I got this. You're like, brain, stop it. I got to do the steps, or you got to do weird shit like put a 16 there. It's what our brain wants. It sees numbers and it says, put them together. Yeah. You're like, brain, calm down. Anything else from homework stuff? Yeah. Or either way.
For 2.4, how is it alright if you just wrote the answer? Because
Oh yeah, a lot of those is just conversion. I mean, yeah. So please don't. You have to know when work is not required. Like if I say 7 times 9, you don't write 7 9s and add them up. You should know what 7 times 9 is. So yeah, there's a level of where you don't have to show work. It's just a one-step conversion from percent to decimal or something. That's fine. You don't have to show work then. Yeah.
Number 50, same 2.3.
2, 3. Oh, this one's kind of gross because it's kind of buried, what you're trying to solve for. And it says solve for n. What would you tell the person that puts a 14 here? Or if you are that person, you're like, I would tell them fantastic. Well, that's a problem. There ain't no 19 minus 5 up here anywhere. There ain't. There is not, if I want grammar to be all good. This is 19 minus 5 times this. There's no 19 minus 5 up there, right? So order operations never goes away. You can't just say, we're out of that section. I don't have to worry about that dumbass sum stuff, or Jaron Sally, whatever. Obviously, what's the first thing I do in any equation solving problem? Distribute. It's almost always the first step. What do you get? -5. And you see how, what's the x? Is it positive or negative?
Negative.
Right here.
Oh, that's positive.
And it now is negative because you're bringing a negative in. You can't, two different things cannot happen. You are bringing -5 in. They both are going to change signs. This is going to become plus 5n. You can't do two different things. You're bringing something in. The same thing gets distributed to both. So if that's a negative, both signs are going to change. And now, I mean, where's your n term? There. What's with the n? This business. Right? I see too many people do this. Is that a good next step? Why is that not a good next step? Because that's going to...
Yeah, it's just
That's fine. I mean, you're going to have to put stuff over here that's not like terms. So if they somehow made this 19m or something, that's a problem. But if they left m plus 19, but what's wrong here? Why would you do this? It's not going to cancel, right? Now, I understand they're looking at this. They're saying, oh, there's subtraction, but the 19 is positive. Adding 19 is not going to cancel it. But of course, you got to do what? Subtract 19, yeah? And I just got 2 more steps, really, right? I think that might be 4. Is that all right? Who asked that question? It's not done, but 2 more steps and you're done. Is the thing with the n in it by itself yet? No. Get rid of it and then get n by itself. You almost always divide last. Are there other ways to do this? Yes. You guys all right? What's up?
Can you please finish it?
Yeah,
because I'm still on just keep it.
All right, now wait a minute. Are you cool with where we are now?
Oh yeah, yes.
What did I just do from here to here? I got rid of that because I want him alone. Why is he not alone yet?
Stupid.
-5x. So what do I do to both sides to get rid of him? All right, and then what are you going to do to get the n by itself? Divide by 5. All right, 2 steps, and you're done. If you add 5x, I don't know if you're worried about what's going to happen over here. What is m minus 19 plus 5x? M minus 19 plus 5x? There's no like terms. Don't tell me this is -14, -13mx. No, there's no mx's up there. Any more m's? No. Any more numbers? No. Any more x's? No. Nothing to put together. And then just divide by 5, you're done. All right, divide by 5, you're done. Yes? Only if you divide each thing by 5. Now watch, if you do this, and then kill those, and then that stays m and 19, how did they escape being divided by 5? That's not fair. So you could do this and be done. You're done. Or what does it mean to divide this by 5? Divide each piece by 5. Then these could cancel all day long, but these are being affected also. I like it. Yes?
So we just like put that whole side like over 5, and then that's the end of the problem.
You could do that, yeah, totally.
And we'd still like get that right. Then?
Totally, all day long.
Okay.
Even Tuesdays. I don't know,
Especially Tuesdays.
every day that ends in Y, you would get it right. When we get to doing like lines, there are specific forms you have to get it to. Here, I'm trying to solve for n. Is n by itself? Yes. Right. But if this side is something you can reduce or something, or like terms, but yeah, just putting it all over 5, you're done. You're done. All right, cool. Anything else? How many until we're done with 2, 3? I don't know. A couple more questions, we've done all of them. So is that good? Everything? What?
2a equal.
Yeah, there you go. Divide by that. Yeah, you're good. Say it, sorry.
The answer's 5, right? Or is it
Like cancel out the 5.
Yeah, n equals this. Yeah, when you divide by 5, you did it because it wants me to solve for n. So the answer is whatever you get on this side. All right. It's either going to be this, and you're done, or it's going to be m over 5 minus 19 over 5 plus x, because 5 divided by 5 is 1. It's one of those two. You can ask questions, it's all right. 'Cause you all are like, yes? Is that all right? Are we moving on? We're moving on. Oh, you got a question about this? Hold on, yes.
You can do 25.
So that's the P minus Q one?
Yeah.
Yeah. I'm not going to do it. I think I've done too many already, but I will say something about it. This wants you to solve it for Q. Why is Q not by itself?
Yeah.
You got a P and an R. And they're both P and R are positive. So how do you get rid of P and R? Subtract. The big mistake I see is somebody will do this, let's say, and then they'll write this. What mistake have they made? There's a mistake. The Q is negative. Where the hell did that go? So if you look at your homework, a lot of you guys, I'm putting a little arrow saying, where the shit did that go? It's not attached to him and he kind of like falls off on the way. It's down here. There it is. It fell down. Ah! No. Right? It is negative Q. It better still be negative Q. Right? And then this is 2 steps away. Right? Why is the Q not by itself? That dude? And then have you solved for Q yet? No, you got to divide by negative at the end. Okay. All right, so let's get back. We desperately have to get in. I don't know if you guys are trying to keep word problems away, but it's going to happen. So hopefully everybody's got that sheet now, the word problem sheet. Well, one side is percentages, the other side is word problems. Yeah. Thank you.
We have one extra.
Thank you. So we did the percentage side already. Yeah, let me keep this one. It's got a bit.
I appreciate you.
I appreciate you too. All right, let's see. So we actually did a problem. Was it Fred and Barbara making money or something? Let me see. Let's do one. Let's watch this one. So before we get to this, these are examples you can kind of use, sit next to you as you're doing your homework. You can kind of reference it. Those examples on that word problems handout. Let's say I had a triangle. There's a triangle, and the shortest side is 5 feet smaller than the middle side. And everybody with me so far? So the shortest side is 5 feet smaller than the middle side. And the longest side is 2 feet longer than twice the middle. And I tell you, the perimeter is 37 feet. Now, I desperately want to explain this. It's really easy to discount word problems. You all think it's just, it only is in this class, and it's nothing to do with real life. And on one level, I agree with you, because a lot of the problems we do are very kind of stupid. It's like, just measure your damn thing. Or Bob put money in the bank, he forgot how much. I'm like, Bob, I wish I had that problem. Did he put 40,000 in this one or 50,000? Like, shut up, Bob. But the steps and logic that you learn in doing these are applicable to a wide range of things, right? Constructing equations that model something in real life. How do they predict the weather? They constructed equations using the variables that represented air density and temperature of the water and all that stuff, and wind or speed. Plug them in and they can try to predict. They're constantly trying to make them better. Believe it or not, it's better than it was like 20 years ago. Doesn't feel like it, but oh well. So, we make relatively simple problems so you can kind of check your work. You can kind of figure out what the numbers are just by kind of playing with the numbers. But you get practice with how to set the problem up, how to translate from English to math, right? Okay, so this piece of information is going to help me with the equation. The first step of a word problem, if it's a geometric problem, you draw an example picture for yourself. So make a triangle. And then you label the sides. So who are your players? What are the players in this problem? How many players are there? 3. What are they? Shortest?
Longer, smaller than middle side.
No. What are the players? Shortest? Middle? Longest. Now the reason I don't mean to come at you like to snap at you, but if you think you're supposed to be able to set up an equation after reading a word problem once, you're insane, right? So if that's what you think you're supposed to be able to do, you are never going to live up to that shit. Your first step has got nothing to do with math. It is pure English. What are the names of the things involved? Because then I have to translate them into math names, and then I could start to set stuff up. If I don't know what my parts are mathematically, how can I put the whole damn thing together? So I think a lot of you guys you think you're supposed to be able to jump there, like, holy shit. No. So first step, what are the players? Draw a picture if it makes sense, right? So now the next step is, which one of these is going to be just X? So which side will be just X?
The shortest and middle.
Interesting. Which side do the other two sides depend on? See how the shortest
the middle.
is blah, 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 middle. The longest has got something to do with the middle. So don't I have to know the middle? If I knew the middle's value, couldn't I quickly figure out the other two?
Yes.
So if I told you the middle was 8 feet, what would the shortest side be? 3 feet. And what would the longest side be? Twice the middle, 16, plus 2, 18. See, so if you knew the middle, you could set up what the other two are. Do I know what the middle side is? No. But I identified it as being the starting point. If I call it X, because I don't know what the shit that thing is, but it's my starting point. Then I have to know first. How can I write an expression for the shortest side now? What would it be? Beautiful. Not 5 minus 6. It's where you start getting negative side lengths. That's a really freaky triangle. Look at this triangle. It's a black hole. It's like, what the hell's negative length mean? So this is X minus 5. 5 feet less than the middle. X minus 5. How can I write the longest side now?
2x plus 2.
2x plus 2. I love it. 2 feet longer than twice the middle. So almost the most important step is who's x, because that sets up everybody else. How do you tell who x is? Well, it's what the other stuff depends on. Bob makes 2,000 more than twice what Fred makes. Oh, then I got to know what Fred makes. I got to call him x, because then Bob is all this shit to do with Fred. It's what the other ones depend on. That's where I start. That's what I call x, or whatever the hell you want to call it. I could have called it m for middle. Makes sense? Now, what's my equation? If I label this, x minus 5, x, 2x plus 2. It doesn't have to be to scale. It's nice to have a little visual, though. What's supposed to happen? The perimeter is supposed to be 37 feet. So, the perimeter is 37. What's the perimeter of the triangle that I've drawn here? No. That's what it's supposed to be. What is the perimeter of this triangle sitting there? Look at me. What is the perimeter? I just do what with the sides? Add them all up. So it'll be x minus 5 plus x plus 2x plus 2. If I add up all the sides and force it to be 37, I can figure out what the sides are. Okay, I like it. So this kind of thing can help you figure out how much material to order if you're trying to create something. You don't want to order like 1,000 more yards of material than you need. You can kind of guesstimate from the beginning by setting up math equations. Oh shit. Don't be putting no math in my life, Jim. Now it should be the easy part, right? What do I get? XX, 2x, 4x, negative 5 plus 2. Yeah, add 3. Divide by 4, you get x is 10. Now don't circle that and just go to the next one. What does that mean? 10 what? Feet. Please, dear God, I am a dork. I know I'm a dork, but don't make me be extra dorky. If you don't put up units, I'm going to put 10 bananas, 10 shoelaces. It's like, really, Jeff? 10 light years? Shut up, Jeff. But you got to put units, right? So then what's this? 5 feet. Because x is 10. 10 minus 5 is 5. And then what's this?
22.
Yeah, 2 times 5 is... Wait, what was x? 10. There you go. 2 times 10 is 20. Plus 2 is 22. Thank you. Now, how do you kind of check yourself? There's the symbol for feet. How can you check yourself? What are these supposed to do? Yeah, 5 and 10 is 15 and 22 is 37. You can check it. Do they do what they're supposed to do? That's nice. All right, maybe. So a lot of students, I think, they make word problems harder. You think because I'm putting more steps on you that makes it harder. This step is stupid important. How did I get the equation? Because I saw all these. How did I get all the answers? Because I saw these. This helps you set up the equation. This helps you answer the question. You skip this, you're kind of crazy. Okay. So look at this. I gave you a triangle problem on here, so you can kind of reference that. That's a nice geometric one. I also gave you one that's not geometric. It's just people at a concert. Who are the players, men and women? Men has got to be X because there were 3 more than twice as many women than men. So however many men there were 3 more than twice that women. So I got to know how many men there were, make it X. 3 more than twice women, 2x plus 3. And then I tell you the total number of people, so you set up the equation, and you solve it. So I want you guys... 2, 3, and 4 are problems like we just did. Number 1 is easier than that. Number 1 is just one step away from being an equation. You see that? When 9 is added to 4 times the number. The result is 37. Can you set that equation up and then solve it? Yes. So do those 4. You can get help from people near you or me.